Welcome to example number 5. Well, these last few examples are really similar to what we should have done back in forces, but we're just doing it now because you'll see after this example we'll start to get into spring potential energy. Anyhow, let's get on to the problem. We have a spring with a spring constant of 125 newtons per meter, and it's used to pull a 25 Newton wooden block horizontally across a tabletop at constant speed. So let's kind of draw a picture if we can. So let's say this is the spring attached to the block and it's not moving at all. Then we decide to apply a force to it, and where it's moving to the right at constant velocity. So now the block is being pulled to the right by a force F. Let's just draw this hand being pulling it to the right, and it's moving at, say, a constant velocity to the right. So I would then draw a free body diagram for the block. We have the vertical forces of the normal force and the force of gravity going down, and these are equal and opposite. We also have the forces acting to the right and to the left. The force acting to the right is due to the spring, which we'll label as F sub s for the spring force, and the force to the right, and the force to the left would be the force because there's friction, right? Otherwise, it would be accelerating to the right. So there's got to be some opposing force that is balancing out the other force, and that's going to be called the force of friction. Remember that the velocity is constant, which means that the acceleration is 0. So the sum of the force in the x direction is 0. So the question is asking how much does it stretch by from the equilibrium length. So this is the equilibrium length. We want to know what this stretch distance is. So this is equilibrium. This is when it's stretched. So really what they're asking for is what is this distance here. I'm looking for delta, actually not y, let's call it delta x. Okay. So how are we going to find delta x? And we have the following known information. We have the spring constant, which is 125 newtons per meter. The wooden block is being pulled across to the right. The wooden block, 25 newtons, what is that? Is that the spring force, the frictional force, the normal force, gravity force? What do you think it is? Well, they don't really tell you the spring force if you look carefully. This is actually the weight of the block. So Fg is 25 newtons. Some people might confuse that, think it's the horizontal force, but no, that's actually the weight of the block. You're also given the coefficient of kinetic friction, which is 0.2. Okay, so we're trying to find delta x. Okay, so let's go ahead to our solution here. So it's all about Hooke's law. So hopefully you might be thinking, well, F sub s, the absolute value of that is equal to k times the absolute value of delta x, or just x. I've got k, yeah, but I don't know the spring force. So I have to find the spring force. I've got the force of gravity. It'd be nice if they just told me the spring force, but that's not that easy, actually. So how do we find the spring force? What's the spring force equal to? The frictional force, because it's balanced, remember? So the sum of the forces in the x direction balance out to be 0. These two must be equal to each other. The spring force, the magnitude of the spring force must be equal to the magnitude of the frictional force. All right? But you don't know the frictional force, but you do know the coefficient of friction. So the spring force is equal to, if you recall, the frictional force formula is mu sub k, kinetic friction, coefficient of kinetic friction, times the normal force. You don't know the normal force. Well, you actually really do. The normal force is balanced by the force of gravity. That's because the sum of the force in the y direction are 0. And so the normal force, must be equal to the force of gravity. And the force of gravity is given as 25 newtons. So let's go ahead and substitute that into here. The spring force would be equal to the coefficient of kinetic friction, 0.2, multiplied by the normal force, which is 25 newtons. That gives you a spring force that is equal to 5 newtons of force. So now you know the spring force, you know the spring constant, so you're ready to figure out the extra stretch distance. So the extra stretch distance, x, is going to be the spring force, the magnitude of the spring force, divided by the spring constant. So that would be equal to 5 newtons divided by 125 newtons per meter. And that gives you an answer of 0.04 meters, which is the same thing as 4 centimeters. Okay, that's it.